What's up, everybody, and welcome back to another video from the Scalar Learning channel. And today we are taking the May 2021 SAT, which was officially released by the College Board, which is amazing. So I got the QAS and I'm ready to take the practice test. I haven't looked at it, so this is gonna be the first time that I'm going through it. So I'm really excited to check it out and see the difficulty level and see the type of problems that were most recently given. If you haven't seen my videos and you're watching this for the first time, I do take these tests in real time for the first time. So you're seeing an authentic test taking experience. And I have, as I mentioned, because it's in real time, I'm setting a timer. So you're going to see that not only am I explaining how to do the problems and showing you my methods, my strategies, but I'm doing it within a time setting to show you that it's not just like a slowed down version. Then how do I speed it up? This is all within the time frame. All right, here we go. My favorite section, no calculator. We got 25 minutes on the clock. We are going to start in 3, 2, 1. Let's do it. And begin. All right, here we go. Two lines intersect shown. What is the value of x? So these are vertical angles, so they're equal to each other. Let's set them equal like this. Going to subtract 5x from both sides. Going to add 35 to that side equals 40. Divide by 2, x equals 20. Boom, done. I'm going to plug it back in just to make sure. 140 minus 35 is 105. 100, 105. Yes, verified. See, I plugged it back in just to make sure. Here we go. Absolute value. What's the positive solution to the given equation? Now, I could probably do this mentally, but I'm just going to split it how I would normally solve it. You bifurcate it into two equations. 2x minus 4 equals 8 and 2x minus 4 equals negative 8. We want the positive, so I'll disregard this one. I'm pretty sure that's going to give me the negative one. Add 4, boom, 2x equals 12, x equals 6. And then we're going to verify by plugging it back in. 6 times 2 is 12, minus 4 is 8, boom, done. 3. Which of the following is equivalent to this? All right, so what they've done is they factored it. My assumption is you can factor out a 4x squared. That's the GCF. What's left inside would be x plus 2, 4x squared, x plus 2, boom, done. And if you redistribute it just to make sure, 4x cubed plus 8x squared, double verified. All right, now we go to number 4. 2n plus 12 equals 26n. What's the value of 6n? All right, so this is going to be one where they're kind of giving us a layup here. You don't have to actually solve for n, just 6n. That's their little hint. So I'm going to subtract 2n from both sides. 12 equals 24n. I'm going to divide both sides by 4 because I don't care about n, I just care about 6n. And then 24n divided by 4 is 6n, 12 divided by 4 is 3, boom, done. We'll just make sure, double verify. If 6n equals 3, sorry, n equals a half, so that'd be 13 equals 13, yes, okay. 5. Quadrilateral ABCD is shown. Which equation shows how the measures of the angles of the quadrilateral are related? All right. Okay. So every quadrilateral adds up to 360 for all 4 angles. So what I need is x, that one is 90, plus this guy equals 360. So I think I said that right. 360 degrees, all the angles in a quadrilateral. This one looks correct. Hold on, let me just make sure. I don't know why this is multiplying by 4. That doesn't make any sense. This one is disregarding the... This one is disregarding the 90, so that's out. I don't know where that 4 is coming in. So yeah, that's the one we thought. Boom, done. Number 6, in right triangle ABC, the length of side AC is 12. The measure of angle A is 40. Wait, hold on. I should draw this out. So let's do, the only thing is I don't like about this whiteboard, it's kind of not my favorite for drawing things like this. See, it does this weird curvy thing and I have to reset it. Okay, so we got that. We got a right triangle. But always draw out the shapes if they mention one and they don't give it to you, right? So that's a great rule of thumb. Here's my right angle because they did say it's a right triangle. Okay, AC is 12. So I'll say A, B is the right angle, and C, AC is 12. A is 40, that means C is 50. Just put it in, why not? Which of the following can be determined using the information below? Yeah, the measure of angle C, yes. The length of side AB. Well, actually, we could use trigonometry to find AB. So technically, both of them, it's definitely 1. So this is out and this is out. The question is, do they want you to use trig? Because all I have to do this one is cosine or tangent or cosine as well, but let's just say cosine of 40 equals AB over 12. So as long as they are including that, which they must be, right? Because trig is is tested on this test, so I have to believe it's C. Now we'll check the answers at the end. All right, number 7. In the xy plane, the line L has a slope of 2. Line K is perp to that, which means line K is going to have a slope of -1/2. Negative reciprocal negative, and then the reciprocal is 1 over that. And it contains the point 42. Okay, so I'm going to use point slope because they give us this nice point here, y, and I say y minus the y value, which is 2, equals the slope times x minus that corresponding x coordinate. Obviously, they don't give us in point slope. They're giving it to us in slope-intercept form, so let's distribute. And when I say slope-intercept form, I'm really just saying isolate the y. Isolate the y. That's it. So then I'm going to add 2 to both sides. Boom, boom. And I get y equals -1/2 x plus 4, which is D, done. Now, let's double check. I'm going to plug, first of all, it has the right slope. I'm going to plug 4 in and make sure I get 2. 4 times -1/2 is -2 plus 4 is 2. Correct. 8. The given equation relates variables c, x, and y, where c is greater than 0. Okay, and blah, blah, blah. Great. Which equation correctly express? Okay, all they want you is to, this is a isolating quantities question. All this is more or less irrelevant. So I'm going to multiply both sides by y, and I get yc equals x, and then I'm going to divide both sides by c because they want y in terms of, when they want y in terms of c and x, they just want you to isolate y. Y equals x over c, boom, done. Number 9, the function f is a linear function. The y-intercept, the function f is a linear function. The y-intercept of the graph of y equals f -2. Okay, what is the y-intercept of the graph? Okay, so if I'm adding 2, right, this is just a vertical shift. So my current line here is whatever. It's going here at -12. And it's shifted up. So now it's going to be shifted up here. So now the y-intercept would be at -10. That's it. So graph function y-intercept, y f of x. What is the y-intercept of? Okay, 0, -10. That's my y-intercept, and we're good to go. Let me just make sure. Y-intercept the graph. It was at -12, bumped up by 2. Yeah, okay, good, done. Numero 10. Which of the following is our x-intercepts of the graph? Okay, x-intercepts are where y equals 0, which we, okay. So I'm going to, okay, I don't need to plug in anything. This is out because 0 is not going to be a y, it's not going to, did I say x-intercept or y-intercept? Anyways, x-intercept, the y value equals 0. Just making sure I didn't trip over my words. But this is not going to be an x-intercept because you can't plug 0 into this because you'll be dividing by 0. So that's out. But 2 and -3 are legit because they make the numerator go to 0. That's what we're looking for in our x-intercepts. So if you plug in -3, you do get a 0 value. Same with 2. So 1 and 2 only. C, done. Now we go to 11. The graph of y equals 2 to the x minus a is shown where a is constant. What is the value of a? All right. First of all, okay, wait, hold on. Let me see. A. All right. So the way we can figure out a is if I plug in 0, wait a minute. Let me think about this for a second. Okay, so normally 2 to the x would have a y-intercept of 1, right? Because if you plug in 0, let's see if I can kind of graph it out. It's like 2 to the x is kind of like this, normally. Something like that, right? And so a is 4 because it's been shifted down by 4. Because normally we'd have that, and then now it's shifted down by 4 to get you to a y-intercept of -3. So I believe that's right. Let me just think about it for a second. And then let me plug in another value here. Let me get rid of my graph. Okay. So if I plug in 2 squared 4 minus 4 is 0. Yes. If I plug in 1, 2 minus 4 is -2. Yeah, it's 4. Okay, good. Next is number 12. See, now they're going to get a little bit trickier until 15. For a certain group of fish, the graph models the relationship between body length and tail area. Body length and tail area. So this is area, and this is body length. Okay. And tail area in square centimeters, where L is between 6 and 34. So 6 is right here. I guess this must be 34. Great. Which equation represents the relationship between body length and tail area? Okay, let me think here. So we've got these different values. I mean, I'm just tempted to plug and chug because let's see, 3.23. So the question is the constant. So I know, okay, let's say, let me find a couple coordinates. So I see a nice coordinate here of 15 comma 5. Great. And then I see another coordinate. Any good ones? That's a really good one. Okay. Let's see what we can do here. And by the way, this is the L value. This is the area. Oh, first of all, it's got to be A because otherwise all of these, do you notice here how 15, I'm getting a length of 15 and I'm getting a smaller A value. This is the only one that's going to give me a smaller area. All these are going to give me bigger values, right? I don't even have to do too much math because 15 squared is 225. And then 225 times something greater than 1 is going to be bigger than 225. I'm trying to get a much smaller value of only 15. Now I'll do it just for fun. So 225 is what that would be. And then if I multiply it by 0.02, it's really just doubling it to, what is that? 450, right? 10, 5, and 4, and then move it over twice, 4.5. And that's, okay, so I said 15.5, maybe it is 4.5. It's a little underneath, but it's pretty close. So this is the winner, done. We don't need to check any other values. I'm pretty confident with that. Where's 13? If xy is the solution to the given system of equations, what is the value of x? Okay, system of equations, let's solve. Let's use elimination. I'm going to multiply the top by 3. See how the y's are already opposite signs? That's nice. I'll multiply that by 2. So I got 24x minus 12y equals 21. Then on the bottom, I got 6x plus 12y equals 24. I'm going to double check my numbers to make sure I didn't make any silly mistakes. 24, negative 12, 21. Sometimes I've forgotten to distribute right to the other side. And then you're kind of hosed. You have to back it up. 6x, 12y, 24. Okay, combine, cancel. 30x equals, what is that, 45? 45. So divide by 30, x equals 45 over 30. Divide top and bottom by 15. That's 3 over 2, which is 1.5. Done. Okay, next is 14. We're almost to the free response. In the given system of equations, k is a constant. The system has exactly one solution. Which of the following could be the value of k? Now, very important. If it has no solutions, the lines are parallel. Infinite solutions, the lines are the same. They're the same line. Well, they can't be the same line. They have different y-intercepts anyways. One solution just means the slopes have to be different. Well, obviously, then k, since k represents a slope, and that guy's a slope of 2, we can't have 2. 5 works, so 5 is good to go. So 2 is the winner, and we're done. That's it. You don't need to do anything else. The given function b models the number of flower beetles in a certain area, where t represents the number of days after June 1st. So on the 0, it's June 1st, 1, it's June 2nd, etc., etc. Which of the following is the best interpretation of 1.11 in this context? So this is obviously an exponential function. It's growing by 11% every day. The model predicts that there were approximately 100 on June 1st. Not that. This is the initial value. The model predicts that the number of flower beetles in this area increased by approximately 1.11 each day. This would be great if it was a linear equation. We'd be adding 1.11. It's not. C, the model predicts that it will take approximately 1.11 days for, no, that doesn't make any sense. Because it doesn't even double in 2 days, right? It would be, if I can try and do it, it would be about like 22% growth or something in 2 days. So that makes no sense. It's got to be D. The model predicts that the number of flower beetles grows by a factor of approximately 1.11 each day. Yeah, I mean, it's true. It's not like I said, the wording I prefer is it grows by 11% each day, but it's the same thing. All right. Free response. Here we go. 16. So now we should see a dip in difficulty until about 18, or probably about 18, 19. In the xy plane, the graph of this, where b is a constant, intersects the axis at negative 6, 0. Okay, so it has a point at negative 6, 0, plug and chug. So plug in 0 for y, negative 6 for x, and solve for b. So 0 equals negative 3 plus b equals 3. And that is the answer. Now I'm going to plug it back in and make sure y equals 1/2 x plus 3. And if I plug in negative 6, yeah, I get 0. Okay, nailed it. Next, 17. For part of a trip, a car traveled directly away from its starting point at a constant speed. The graph shows the car's distance from its starting point. So here it's 110 away, 115, 120, etc. at these various time stamps. The graph shows the car's distance in miles for times from 2 to 2.5 hours. So here's 2, here's 2.5. Cool. What was the speed of the car during this part of the trip? Got it. So again, speed is rate. I always go back to distance equals rate times time. By the way, if you notice, I'm spending my time making sure I understand this graph perfectly before I dive into the question. I'm not like jumping in and then going back and trying to understand it. I'll take my time and make sure this is clear to me. And it's clear to me now, so I'm happy. So distance equals rate times time. Just using this equation, we know that distance divided by time equals rate. And that's what we're trying to get, right? Well, what is the distance that it traveled in the span? It went from 110 to 135. That's 25 miles, all right? And in how much time? Because they want it in miles per hour, right? And this is in hours, perfect. It's gone in 0.5 hours. So that's 25 per 0.5 hours. And you know, it's not the calculator section, so we can't do it on a calculator, but it's not so bad. It's really 25 divided by 5, which is 5. But since it's a decimal, add a 0. So it's 50 miles per hour. We don't need the label, 50. Let me just make sure and think about that. So it's gone 25 miles in a half an hour. Yeah, it's 50 miles per hour. Cool. Number 18, in the XY plane, the graph, they're giving us a circle. Okay, I told you guys, I've said it many, many times, you got to know the circle equation, you got to know how to put it in standard form, because this is not. So this is on the harder side. So we use completing the square. We take half of this value and square it, which is 4 squared is 16. By the way, I'm going to put the other side here, and I'm going to add that 16 there. So I'm going to do it simultaneously so I don't forget. Then for the y squared, I'm going to do the same thing, 10y. And then half of negative 10 is negative 5 squared is 25, but I'm going to add 25 here too. Okay. Now this is perfect for factoring to get it into standard form. I don't need to factor the left side because all I want is the radius, which is the square root of what's on that side. But let's just do it anyways, just for fun. So it becomes x minus 4 squared. It's a perfect square. If you don't believe me, FOIL it. You'll see you get this. Same with this is y minus 5 squared. We built these nice perfect squares. So the center is at 4, 5. Not that you need to know that. And then we have to do this mentally. And it's 41 plus 40, which is 81. That's a good sign because it's a perfect square and it's in the free response. So we want a nice whole number. And square root of 81 is 9. So, you know, you want to be careful. You want to remember that's not the radius. This is the radius squared. Number 19, what is the sum of the solutions to the equation? Factor and solve. This is surprisingly easy for number 19, but it is what it is. Oh, wait. Hold on. Am I wrong? Oh, my. No. It's not factorable. Okay, sorry. So it was not as easy as I thought, but you can use a shortcut here. I told you guys with those precision formulas in that video that I sent out, right? Sum of the solutions is negative b over a. Nevertheless, we got 8 minutes to spare, so we got plenty of time. I'll show you how to do it even if you don't know this formula. But the sum of the solutions is negative 6, which is 6 over 1. The answer is 6 and you're done. So you know that formula is so easy, but if you don't know it, just use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. This becomes 6 plus or minus 36 minus 28, which is 8 over 2. Now, all we want is the sum. So remember, I'm not even going to simplify this too much. We want the sum of these two solutions. 6 minus square root of 8 over 2. Notice that these two are opposites. They cancel out. What do I get? I get 12 over 2, which is 6. Okay. Last one, number 20. We got 7.5 minutes to spare, so it's great. In the given expression, a is a constant. The expression is equivalent to x to the 6th. Hold on, let me think about this for a second. So that's the square root. That's the third power. So I'm going to turn this into its rational root equivalent. So since it's cubed, that's in the numerator. Square root, that's like in the denominator, that's a 2. So it's this to the a power, which is the same as a to the, what am I doing? It's just x to the 3/2 a, right? Because they just multiply. And they're saying this is equivalent to x to the 6th. And once the two bases are equal, I can kind of cancel them out. 3/2 a equals 6. Multiply both sides by the reciprocal. Cancel that out. 2/3 of 6 is 4. So a equals 4. Let me just double check. So that's to the 6. So if I did that to the 4th power, so really what that would be is the square root of x cubed 4 times. I don't really need to do this, but let's just do it anyways. Here, x cubed, cube root. Okay, so this times this is x cubed because you're undoing the square root. That times that is x cubed, and then x cubed times x cubed is indeed x to the 6th. All right, we're done. Now, of course, we have 6 minutes to spare. Now, if this was a normal test taking, like a real test, obviously, if I was doing it for real, I'd be using all this extra time to check my answers, but it doesn't really matter here. We're just going to check the answers and see what we got. All right, hold on. I just had it open, right? Let me find it. Okay, I think we got the answers at the end of this. Although I have not checked, but I assume it's at the end. Okay. Yeah, we got them. Okay. Writing, reading, no calculator. Here we go. Let's zoom out and go to the beginning. All right. Number 1, we got BCCC. Let me make it a little thicker. BCCC. Number 5, we've got ACDD. ACDD. My God, so many messages. All right, number 9 is BC. BC. 11 is AA. Okay, 13 is ABD. AB. Perfect. Okay, we got all of those correct. Amazing. Now let's look at the free response. 16 is 3. 17 is 50. 18 is 9. 19 is 6. And for the win, 20 is 4. Okay, excellent. I'd rank this in terms of difficulty as kind of like medium, easy to medium in terms of other no calculators that I've seen, but still pretty challenging. And that's it. All right, cool. And the calculator section is coming shortly, hopefully later this week. I hope you guys like this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I will see you in the next video. Take it easy.